So today we're going to dive into something called Agent KB. It's a really cool new framework that's trying to solve one of the biggest headaches in AI right now. How do you give AI agents a kind of shared collective memory so they can finally stop making the same mistakes over and over again?
You know that feeling, right? You've got this incredibly powerful AI, you give it what seems like a pretty simple task, and it just completely whiffs. It's super frustrating, and it really points to a deep, fundamental problem. We're going to unpack exactly why that happens and look at a fascinating new way to fix it. Researchers have a great name for this. They call it AI's Groundhog Day problem. And it's perfect, right? Because without a way to learn from past experiences, and not just its own, but from other AIs, an agent is basically stuck in a loop, doomed to make the same errors again and again. Okay, let's look at a real-world example. Here, an agent needs to figure out the distance between two atoms in a protein file. Seems easy enough. But on the left, you can see the agent working all by itself. It makes a classic blunder. It just grabs the first two lines of the data file. The problem? Those are water molecules, not the protein atoms it was actually supposed to be looking at. So the whole result is just wrong.
So why does this happen all the time? Well, the research boils it down to three big flaws. First, agents are basically working in silos. Their experiences are isolated, so they can't learn from what another agent did. Second, even when they look at their own past work, they can't really tell the difference between a high-level strategy and a tiny implementation detail. And third, they often just replay old solutions word for word without really understanding the lesson behind it. It's pretty much a perfect recipe for failure. So how do we break AIs out of this loop? The answer the researchers came up with is what you might call a shared brain solution. And now, look at the difference. It's the exact same task. But this time, the agent is hooked into Agent KB. By tapping into that shared knowledge, it instantly knows, oh, I should ignore that irrelevant water molecule data. It skips right past the junk and correctly finds the actual atom records it needs. That one simple learned lesson guides it straight to the right answer. And that is the power of Agent KB in a nutshell. It's a shared knowledge base, like a collective memory for AIs. It takes all these problem-solving attempts from the past and distills them into useful strategies and lessons. This lets any AI connected to it learn not just from its own history, but from the successes and, just as importantly, the failures of every other agent that came before it. Now, this all sounds great in theory, but how does it actually work under the hood? The secret sauce is in this really innovative model called the teacher-student approach. What's so great about this model is how simple and elegant it is. You have a student agent, and its job is to actually try and solve the problem. Then you have a teacher agent that watches the student, kind of like a coach, providing expert feedback and corrections. And the key is that both of them are pulling their wisdom from that same central knowledge base. Both the teacher and the student follow this simple but really powerful three-step process. First, they reason about the problem at hand. Then, they retrieve relevant lessons from the knowledge base. And finally, they refine their own plan based on that new wisdom. Reason, retrieve, refine. That's the core loop. And they each have their own special job. The student is focused on the big picture. It retrieves these high-level workflows to get a general game plan together. The teacher, on the other hand, acts more like an expert coach. It zooms in on the nitty-gritty details of the execution, retrieving very specific, granular lessons to correct mistakes as they happen and perfect the overall approach. But hey, a great idea is only as good as its results, right? So does Agent KB actually work? Well, the proof is in the numbers, and they're pretty impressive. First up, let's look at the Gaia benchmark, which is a test for general-purpose AI assistants. With Agent KB, the success rate jumped by over 6%. Now, that might not sound like a huge number, but in the world of AI benchmarks, getting a boost like that is a very, very big deal. And it gets even better when you throw it at something really hard. On the SWE bench, which is all about fixing real software bugs from places like GitHub, Agent KB boosted the success rate by a massive 8.67%. That's a huge gain on a super difficult real-world task. And what's really cool is that this isn't some fluke that only works with one specific AI model. The improvements are consistent right across the board. You can see it here, from big models like GPT-4 all the way to smaller open source ones. It doesn't matter what the engine is. Plugging it into Agent KB gives it a clear and significant performance boost. You can literally see the impact on the number of errors. For both of these top-tier models, there's a clear net reduction in mistakes. Agent KB helps them avoid bad plans, find the right information, and even cuts down on simple reasoning errors. It just makes them fundamentally more reliable. So let's just zoom out for a minute. What does all this really mean for the future of AI? Well, it suggests we're on the cusp of a pretty fundamental shift in how we think about and build these intelligent systems.
I think the paper's conclusion says it all perfectly. It's about bridging the gap between episodic memory and cumulative agent intelligence. In other words, we're moving away from building AIs that basically have amnesia and have to start from scratch on every new problem. Instead, we're moving towards systems that build on a shared, collective, and constantly growing wisdom.
And that really leaves us with a final, pretty mind-bending question to think about. For maybe the first time, we're building systems that can learn from a collective past, free from the biases or blind spots of just one mind. If they can learn to do that, what might they eventually be able to teach us about solving our most complex problems?